All right, next section of chapter 2, literal equations. And what we're working on here is we're working on solving an equation. We're going to solve that equation for a letter. Remember that the process of solving is moving everything away from the thing that we're trying to solve for, which today is a letter. And so we're just going to do the opposite to a bunch of different things to get our letter by itself. So we're going to see multiple variables in here. We're trying to solve for a variable and not a number. It involves lots of manipulation and moving things. And again, the goal is to solve by moving everything away from the letter that we're trying to solve for. So we've got the equation 4m minus 3n equals 8, and they want us to solve for n. So the first thing that we want to do is get the variable by itself, right? We want to isolate the variable that we're solving for. So I'm just going to write our equation here, 4m minus 3n equals 8. And if we're solving for n, we're focused on getting m by itself. So it looks like the first thing that I want to do to get like the variable term or the variable piece by itself, right, which is this 4n, is to remove the minus 3n. So the opposite of subtracting 3n is to add 3n. I want to make sure that we do that to both sides. So now we're at 4m equals 3n plus 8. Remember that 3n and 8 are not like terms, so we can't combine them. The best we can use is just write them on the same side of the equal sign. So let's go down here. We've got 4m equals 3n plus 8. We want to get m by itself, right? We don't want 4m. We want just the letter m. So in order to get rid of the 4 that's in front of the m, notice you don't see a sign between those two, which means that we are probably multiplying. And we know that the opposite of multiplying is to divide. So let's divide this by 4. If they're multiplying m by 4, we should divide by 4. If we divide by 4 on one side, we want to make sure that we divide by 4 on the other side. My 4's cancel there, and I have that m equals just this kind of messy looking thing, 3n plus 8 over 4. If you want to be like as simple as possible, here's what I would do. I would say that m equals, if you have a common denominator of 4 among like 1, 2 terms in a numerator, you can split those up. So you could say m equals 3n over 4 plus 8 over 4. So 4 is your common denominator of both the 3n and the 8. Okay. So to get as simple as possible, m equals 3n over 4. There's really not much I can do to simplify that. But that 8 over 4, we can reduce that to a 2. And that's probably actually the best, most simplified version of the answer. Right? We've got the equation solved for m, and then we've reduced everything on the other side that we can. So I think that's what I want us to get to today. All right, so now we've got the equation 15 equals 3n plus 6p, and we want to solve it for n. So first thing I want to do is work to get this piece by itself, because that's the piece that has n. So they added 6p to that. Let's do the opposite and subtract 6p. Make sure we do it to both sides. Those go away. I could write this as maybe 15 minus 6p is now equal to 3n. I need to get just n on its own. They're multiplying between the 3 and the n, so I should divide by 3, divide by 3, divide by 3. And look at that. I can do a lot of simplifying on the left-hand side. 15 over 3 simplifies to 5. Minus sign. 6p over 3 simplifies to minus 2p. And that's equal to now just n. So I've got n solved for. I've got everything on the other side simplified. And that's the best looking version of that equation that we could produce. All right, so we've got our equation k minus 2 over 5 is equal to 11j, and they want us to solve that for k. So I'm just going to rewrite down here, k minus 2 over 5 is equal to 11j. If we're trying to get k by itself, that means we want to get this variable piece of k minus 2 by itself. And they're dividing that variable piece of k minus 2 by 5, so we want to do the opposite and multiply that entire side by 5, and then jump over here and multiply that entire side by 5 as well. Divide by 5, multiply by 5, go away. We've got k minus 2 is equal to 5 times 11j is just 55j. And now I'm ready to work to get k by itself. So they're subtracting 2 from k, so I want to add 2, do it to both sides. Remember that 55j and 2 are not like terms, so the best I can do is do k equals 55j plus 2. And I've got it solved for k. There's nothing I can do to make that more simple or come out to be any nicer, so I've got it right there. This is a good example. Kids will struggle with this idea just a little bit. So what we've got here is we've got that 28 equals t times r plus 4. And the r plus 4 is grouped together inside of parentheses. And they want us to solve for t. The thing I try to get across to kids is that between the t and that grouping of r plus 4, there's an operation that's going on, right? Many of you would look at that and you'd be like, okay, I need to distribute. And we've talked about how distribution is the same process as multiplication. And we know that the opposite of multiplying is dividing. So if we're trying to get t by itself on one side of the equal sign, and the thing that they're doing to t is multiplying it by the grouping of r plus 4, I think it makes sense that we could do a big division bar here, divide by r plus 4, and go over to the other side and do that as well. So literally on this side, that r plus 4 and that r plus 4 cancel, and I've got it solved for t. I've got that t equals 28 over r plus 4. So that's a handy little trick that you can use if you ever have like distribution. Remember that distribution is multiplication, and to undo multiplication, we would want to divide. So there's my equation solved for t. I think we'll skip over that one. We've seen a few examples with that sort of an idea. And I don't know, let's throw this one on here just for the fun of it. So we're solving for x. And actually notice here that we have a couple of x's that we're working with. So we're going to have to try to isolate that x. And this is kind of an advanced idea, so this will be a good one for us to talk about. So if we're solving for x and we see that we've got a place for the x right here, and we've got an x located right there, we're going to want to try to get those x's together on the same side of the equal sign. Now they aren't like terms, right? This is 3x and that's xz. So they don't have the same last name, so we can't combine them, but it is helpful for us to put them together on the same side. So to start doing that, I'm going to subtract xz from both sides. Okay, so those would go away. Let's see what we have now. We've got a 3x. Remember, not like terms, so I'm just going to write minus xz minus 2y equals just a 5 on that right side. So we're going to get this term and this term by themselves, so I want to undo subtracting 2y. To do that, I should add 2y, do it to both sides. So now I'm at 3x minus xz equals 5 plus 2y. Here's the trick. If you look at 3x and you look at xz, the thing that you see that they have in common is they each have an x. That was the reason that we put them together on the same side of the equal sign. So if they each have an x, the way that we want to isolate that x is by what we would call factoring. So since this term and this term each have an x in common, we can factor out an x from those terms. So if we factor out an x, here's what we have. We've got like x, and then it's almost like a reverse distribution. So think, what would you have to take this x times to recreate 3x? And the answer to that is times 3. And we've got a minus sign. What would you have to take this x times to recreate xz? And the answer to that is times a z. And I can close my parentheses. So if you like mentally distribute here, you can see we're still equivalent to x times 3, which is 3x, minus sign, x times z, which is xz. So all we've done is we've kind of extracted this x from both the 3x and the xz. And that's still equal to 5 plus 2y. Recall that way up at the top, I'm solving for x. So I do kind of have the x by itself, but now I just need to isolate it on the left side of the equal sign. So the way for me to do that is if they're multiplying this x by 3 minus z, I'd want to divide both sides by 3 minus z. That's kind of that trick that we used on the previous example that we did. So this 3 minus z goes away, as does this one. And we're left with that x is equal to 5 plus 2y all over 3 minus z. That's one of the tougher ideas because we haven't really worked with like the reverse distribution idea, which is what we'll call factoring. We've got a whole chapter on that later in the year. But it is kind of a good preview to think about, okay, if each of my terms had an x in common, right here and right there, I can take that out to isolate that x. And that was kind of the trick to make this one solve for x. Best of luck today. Let me know if you have questions. We'll probably answer a few of those tomorrow. But good luck as you work through the rest of these.